For centuries, people have played games for fun or to socialize, and have, in the process, developed their ability to think, to use logic and reasoning as they strategize with the intent to win. Board games, or those played with dice, cards, paper and pencil, or no supplies at all, can all help to build your thinking skills. I'm going to try to hang you in a game of Hangman. I have a 4-letter word, and the objective of the game is for you to guess my word before you get hung. Every incorrect letter is a body part that I'm going to draw en route to you not winning the game. Let's say you guess an A. There's no A, so I'm going to draw the head. E, there's no E. There's the body. I, O, U, Y. Okay, so there is a Y, so I'm going to fill that in there. Now let's say you go with an S, an R, a C, an M, a D, an L. Those are the letters that people most commonly choose first of all. Okay, so we've got 2 of the letters. Can you guess the word? If not, let's keep going. P, F, N. There is an N. And now you guess, and you're correct, the word is lynx. This is my favorite Hangman word. The objective in Tic Tac Toe is to get 3 X's or O's in a straight line vertically, horizontally, or diagonally. People tend to start in the middle, but the problem is your opponent then will go perhaps here, and it's a constant back and forth blocking motion. A good strategy is to choose one of the corners. So if I'm X, let's say I go here. Let's say my opponent goes here. People tend to like that middle box, and then I'm going to go here because I want to get those corners. So even though that diagonal line is obviously not going to be a winner, I'm still going to go there. Let's say my opponent then goes here, I go here, and now I'm guaranteed to win. If my opponent goes here, I'm going to win across the bottom, or if my opponent were to go here, I would win here. There is an element of chance involved in winning a game, but by using some of your logic and reasoning skills, you can improve the probability of coming out victorious. Remember that when we use inductive reasoning, we're taking a look at patterns that exist. We're moving from something very specific to something more general. When we use deductive reasoning, we're taking what we know or assume to be true to come up with a conclusion. So we're moving from something very general and then honing it into something very specific, our specific conclusion. Because your logic and reasoning skills are like a muscle, the more you use it, the better you get at it. Here's a challenge for you. You're going to gather 10 coins or bottle caps or whatever you happen to have. Try to flip that pyramid upside down, and you can only move 1 coin at a time. So for example, if I take this coin and move it here, that is 1 move. Pause the video, and you're going to try to invert that pyramid in as few moves as possible. I can do it in 3 moves. See if you can get 3 or less. Here's what I would do. I would take this penny, and I would move it here. I would take this penny and I would move it here. I would take this penny and I would move it here. I now have 1 penny, 2 pennies, 3 pennies, and 4 pennies. Here's another type of logic puzzle, and another strategy you can use is to try to diagram it out. I know that Sue is playing board games and they're making pairs of partners. If there are Sue and 7 other people, 8 people means 2 people in a pair. I have 4 different pairs that are going to sit around the table. I'm given a list of the names of all participants, which I've just written down here, and then I drew my table. Now, it tells us initially Dave and his partner are to the left of Stu. It doesn't matter where I put Dave. I happen to put him here, and his partner is going to go on this side with him. Now, you have to imagine Dave is sitting at the table. There's his feet under the table. He is to the left of Stu. So that means Stu has to go here. And then again, if you imagine Stu is sitting here, his legs under the table, Dave is now on Stu's left. It tells us that across from Dave is Sue. So if here is Dave, across the table over here, we know we have to put Sue. And then I'm going to cross the people out as I use them so I can see kind of who's left. And we also know Sue is to the right of Josh. Okay, so if this is Sue sitting here, Josh has to be here so that Sue is to Josh's right. So I'm going to write down Josh, and again, I'm going to cross them out so I can see who I've got left. It tells us that Dave's brother's partner, Tanya, is across from Stu. So if Stu is here across the table, we know we're going to have to put Tanya. And so I'm going to cross her off. And Joy is not on Stu's right. So if this is Stu's right. So Joy cannot go here. That means that Joy has to go here or here. But if we read in the question, it tells us that Dave's brother's partner, Tanya, is across from Stu. So Tanya is paired up with a brother. Look at who's left. We've got Angie, Joy, and Linus. The most likely male name is going to be Linus. So I'm going to put, by process of deduction, Linus there, which means that Joy has to go here. And then again, if you cross these off by process of elimination, that means Angie is paired up with Sue. Just solved that puzzle using deductive reasoning skills. We took a series of facts and then came to a specific conclusion based on those facts. Here's another puzzle where we have 12 players and 2 coaches. So there's 14 people in total. Each one of those 14 people is going to shake everyone else's hand. You're going to figure out how many handshakes were exchanged. One hint, try to perhaps diagram this out. Pause the video, come back, and we'll see your answer. Here's person 1 shaking hands with all 13 other people. So I know they're going to shake 13 hands. Now person 2 has already shook the hand of person number 1. They're not going to reshake hands. So there's only 12 people, 12 different people that person 2 is going to shake hands with. That's enough for me to see the pattern. So I know that as we go down here, each person is going to be shaking with one less person because they're not going to reshake hands. So in total, when I add those up, there's 91 handshakes exchanged. I used inductive reasoning by getting the pattern, extending that pattern, and then coming up with my solution. Here's another logic puzzle, and again, we're going to try to diagram it out to see if we can figure this puzzle out. In this case, we have 3 different objects. We have a goat, a wolf, and a hay bale. We have to get across the river. We can only carry one object at a time along with the farmer, and there's certain objects that can't be left alone. For example, if we leave the goat with the goat is going to eat the hay. If we leave the wolf with the wolf is going to eat the goat. Knowing that information, you have to figure out how can we get all 3 of these objects safely across the river in our little boat carrying only one object at a time. The video and see if you can figure it out. Okay, so here's what I'm going to do. First trip across, I am going to move the goat. I'm going to leave the goat there and I'm going to go back across the river. I'm then going to go back across the river with the wolf. Now I cannot leave the goat with the wolf together, so I'm going to pack the goat back up in my boat and I'm going to take the goat across. So the goat's no longer there, so we're all good. Then I'm going to move my bale of hay across because I can't leave the goat with the hay. I'm going to go back again and I'm finally going to pick up my goat and transfer the goat safely across the river. Sudoku puzzles tend to come up frequently. We're going to look at how you could approach solving one. The objective of a Sudoku puzzle is to use the numbers 1 through 9 to complete every row, every column, and every box using each digit only one time. What you want to do first of all is take a look to see a number that appears frequently, and you're going to use that as a starting point. For example, I can see I've got several 6s in this puzzle. My first row has a 6 already. My second row has a 6 already. This third row needs a 6. Now, I can't put it here because that box already contains a 6. So does this third box here. That means that my 6 either has to go here or here. This row and box needs a 6. Now I can't put it in that last one because there's a 6 there already. So I'm going to fill my 6 in to that square. Only write down a number when you for sure know there's no other place for it to go. If you're not sure if more than one number could go there, you're going to leave it blank. I don't have enough information to fill my 6s into this middle section, but if I skip down to the last row of boxes, I've got a 6 in that first row, I've got a 6 in that third row. So this box and row needs a 6, and then again, I can't put it here because I already have a 6 in that column. So I know for sure that the 6 has to go into that box. This puzzle also contains a lot of 1s. So similar concept, I know that this row down here has a 1, this row has a 1, this row and box needs a 1. I can't put a 1 here because that column already contains a 1, so I know for sure that there's going to be a 1 in that box. I have a 1 in this column already. I have a 1 in this column already, so I know that this row and box needs a 1, so I can fill another 1 in there. Another strategy is to look for a row or column or box that already has the majority of it filled in. I can tell that I'm only missing 2 numbers in this box. I've got 1, 2, 3, 4, 5, 6. I'm missing the 7 and the 8. I've got the 9. So I know 7 and 8 have to go here. I have a 7 here already in this row. So this cannot be a 7. By process of elimination, that makes that a 7, and that therefore has to be an 8. This first row contains a 1, as does the third row. I need a 1 in this row and box. And then again, I already have a 1 here, so I know for sure this has to be a 1. I also know that this will be a 1 here, because this box needs a 1 in the very center. There's already a 1 in that column, there's already a 1 in that column, and there's already a 1 in that row. So by process of elimination, that is going to be a 1 too. And then the only one I'm missing is in this box and row here. Now it can't go here because of that one, it can't go here because of that one, and it can't go there. So then I can fill in my last one is going to go there. I can also see that this column has a lot of numbers filled in. I'm missing a 3. Now I can't put a 3 here because of that one, and this box needs a 3, but I've already got a 3 in that row, I've already got a 3 in that row. So I know that I'm going to put a 3 there. I've got an 8 in this last column, I've got an 8 in the second last column, I need an 8 in this box and row, so an 8's going to go there. And you're going to continue on. As more and more numbers start to fill in, you're going to check, recheck, continue to piece it together, and complete your puzzle.